Okay, in this video we are going to tackle this problem. It's the integral of e to the x times the quantity 1 plus sine of x over 1 plus cosine of x is equal to e to the x times f of x plus c. So I think we could actually solve it without knowing that it equals e to the x f of x plus c, but we were given that, and so we're going to take advantage of it. So let's see. There's actually, I believe, two things we should know before we really dive in. And so the first of them is that sine of 2a is 2 sine a cosine a. So the reason I'm telling you that is that this will allow us to rewrite sine of x. So because of this, we can replace a with x over 2, and we will get that the sine of x is 2 sine of x over 2 cosine of x over 2. So that is one substitution that we're going to end up making in the problem. The second substitution involves cosine of 2a. So cosine of 2a, there's three choices of formula. I'm going to choose the one that involves cosine squared because I know that that's going to make this work out for us. So 2 cosine squared of a minus 1. Now this will allow us to rewrite cosine. So cosine of x, we're replacing a with x over 2, is going to be 2 cosine squared of x over 2 minus 1. So we need both of these substitutions because the thing that we're dealing with has a sine in it and it has a cosine in it. We're going to make our substitutions and then do a little trig on this. I think this is going to work out. So let's see. So here's what we start with. So we want to rewrite it, right? So we have e to the x, 1 plus. We're replacing sine with 2 sine x over 2 cosine of x over 2. So we have this. And then in the denominator, we're going to replace cosine with the formula that we just worked out, right? So it's going to be 1 plus cosine is going to be 2 cosine squared of x over 2 and then minus 1. What's really nice is in that denominator, the 1 and the minus 1 are going to cancel out. So in the next step, that's all I'm going to do. So we've got this, right? All that I've done is I changed the color, and also in the denominator you had 1 and a minus 1. Those are gone. So now what we'll do is we will separate this this fraction into two separate fractions, right? So we have 1 plus something. We're going to break it into two separate fractions. So we're going to have our e to the x times. We'll have 1 over 2 cosine squared of x over 2. So that's going to be 1 over 2 is 1/2. And then 1 over cosine is secant. So we'll make it secant squared of x over 2. Plus, we have 2 over 2. Those are gone. You have a cosine of x over 2 over cosine squared of x over 2. Cancel one cosine in the denominator. So then you have sine over cosine, which is tangent. So that whole second fraction just becomes tan of x over 2. Now at this point, if you look at this integrand, I think you can see that this is actually a product rule because the derivative of tangent is secant squared. It looks to me like we have like e to the x times the derivative of tan of x over 2 plus e to the x times tan of x over 2. I think that's just the product rule on e times tan of x over 2. But the problem gave us this additional part where we knew that it should be e to the x times f of x plus c. So I'm going to take advantage of that. This is a useful technique where you just take the derivative kind of both sides of this thing. So the derivative of e to the x f of x is going to be, first derivative of the second plus second derivative of the first. So e to the x f prime of x plus f of x times e to the x. And then we can take an e to the x out of that. So we get e to the x quantity f prime plus f. So at this point, it's like integration by comparison. We just have to decide which of the two things that are inside those parentheses is f of x. But I'm pretty confident that f of x is going to be tan of x over 2. So if f of x is this, we just need to confirm that f prime actually works out. But because of the chain rule and the derivative of tangent, we definitely know that f prime would be 1/2 secant squared of x over 2. So I think we're good. So that's basically my answer, right? So the integral that we started with is going to be equal to e to the x times our f of x, so e to the x times tan of x over 2, and then plus c. So what we have found by doing all this work is that the integral of e to the x quantity 1 plus sine of x over 1 plus cosine of x is equal to e to the x times tan of x over 2 plus c. So don't be afraid to make those kinds of substitutions. You can replace sine with a double angle for sine. You can replace cosine with a double angle for cosine. Do some trig identities. And then once you've got it down, always be on the lookout for reversing the product rule. Basically, integration by parts is what that's called, is what that is called if you run into it kind of without further guidance. But in this case, they told us that our answer would be something e to the x times f of x plus c. All right, that's the whole problem. I hope this was helpful, and good luck.